So two problems that are interesting in these systems. This idea of proof of work, it's an availability system. It never actually guarantees consistency. It never guarantees that the entire chain is fully committed and never going to go away. What it does guarantee, though, is when you have your Bitcoin and you observe blocks building on top of it, you can calculate how much thermodynamic energy has been spent to secure your Bitcoin, right? You can say, okay, even though this chain is not never going to guarantee that I actually have my Bitcoin, but this $100 million or $200 million or billions and billions upon dollars of electricity guarantee that it's going to take at least that much to take it away from me, right? And that accumulation of that security is a property that is unique to proof of work. At the same time, it's weak it's actually pretty weak at guaranteeing censorship resistance in the same sense that you and me are able to communicate in a peer-to-peer fashion with everybody in the world instantly. Like that instantaneous communication, that like the end general's problem in the moment, if you want to think about it, proof of work is really, really bad at that because you can revert short forks, right? And the way hash power and mining concentrates in a very few set of block producers. There's maybe 5 block producers that add up to 51%. Now, you as a Bitcoin holder, you don't really care about that because every block they produce just makes more your crypto that you're not spending or just storing, in case something goes wrong. It just makes it even more secure. So there's this kind of that side of it, I think, is very well optimized for store of value, but absolutely broken for finance. And finance depends on actually censorship resistance or this ability for information to flow with extremely high reliability in the moment, like right now. One way that I kind of describe it is, you know, these big concrete buildings in Manhattan that stock exchange, they literally have mainframe computers that have CPUs that replicate the exact same instruction. There's an array of these CPUs, and if one has an error, they can hot swap them, right? So they can replace the broken CPU and put a new one in without interrupting the markets because it's so important that it never happens. That piece is fault tolerance, and that's kind of like hard engineering fault tolerance problems. But if I want to trade in that system and I go through all the hoops to get my servers there, they will cut me a cable that's exactly the same length as everyone else's cable to guarantee that my information has fair and open access to these markets amongst all the other participants, that nobody's really getting ahead of anyone else. And that bit is the censorship resistant piece. Right now, like Bitcoin is guaranteeing fault tolerance to a very extremely high degree for like kind of storing your Bitcoin. Fault tolerance isn't quite the right way to correct it, but it's not really guaranteeing that when I submit my transaction, that it's going to be included in like 2 seconds, right? Like neither is Ethereum, um, because there's so much congestion and so much demand, and so few miners control the access to that network that those guarantees are not really applied. There's market forces that allow some participants access, but it's not the same as every market maker in the world, every trader in the world can go take a trade and put it in the system. Um, and this is where Solana shines. How do we maximize the minimum set of entities that could potentially disrupt the flow of information, right? The larger set, the bigger that set gets, the harder it is for all of them to coordinate to do so, the more secure the network is from that information flow perspective, and therefore systems that are running inside of it that are fundamentally markets become fair and more open. And long-term goal for us is, I like people ask me, are we an Ethereum killer? I've never like thought of Ethereum as something to be killed. It's an awesome open source project. Our seed level slide said Solana's blockchain and Nasdaq speed, right? They didn't say Ethereum 2.0. We're targeting more like bigger dragons there, right? Like we
Mhm.
want this like foundational fundamental engine of finance, which is global price discovery. We want that to be fair and open, running on open software, open hardware run by volunteers
Hmm.
effectively, like all around the world.
Hmm.
So that's the fundamental difference between, I think, store of value and proof of work. Um, if you're optimizing for that, and I think what we're doing, which is censorship resistance, like of information flow.
Got it.
How can we guarantee that any two parties in the world in any moment are guaranteed that they can send financial message to each other at a fair and open network?
Okay, so let me kind of summarize. Correct me if I'm wrong here. So with proof of work, right now that's the best we have in terms of kind of store value because it basically pulls together all of the energy that was required to secure that network, which is extremely expensive. Um, and you guys on the other side are not necessarily solving the store value problem, but you're solving a different problem, which is the whole information flow, the flow of information at very fast speeds, also low cost, to create, I guess, market dynamics like on the blockchain in a true sense. I mean, can you explain kind of what's been holding back crypto? I mean, because we have, the promise of DeFi, of crypto to provide that info flow, but it seems like there's lots of gas fees, lots of, different problems. What's been kind of like the Achilles heel or the issue kind of behind all
So
this?
I think projects that came out of Bitcoin, like Ethereum, they're kind of carrying their baggage with them still. They're thinking about store value, self-sovereign money, that as like an important use case, and they don't want to give it up. So I think ironically is they're trying to build these other things that I think much more interesting, but they want to keep that piece, which is impossible to do without just being Bitcoin. So this is where I think like the value that you're adding is removing so much of the original vision of Bitcoin that you're kind of creating a worse overall kind of product or combination of the numbers the all these factors are Pareto efficient, right? The trade-offs you're making, I think, end up not being Pareto efficient. Um, on the censorship resistance piece, the this is from the ground up, ignoring everything about what people think of proof of work and what people think of enterprise blockchain. Like it has none of those things in it. It's really like, what if we had a global price discovery engine? What if you could have this machine, right, that's fully connected, single sharded, there's no compromises on the communication aspect of it, that guaranteed that any two peers that are using it around the world have effectively a fully connected system that, like censorship resistance and general's problem, if you have a solution for that, then all the users that are using that black box, you can consider them fully connected. They're not no longer using an intermediary that can disrupt the information flow from any connection. And if you have that at a global scale and this thing is running markets and doing price discovery, then you've effectively kind of, I think, unleashed this like idea of true peer-to-peer financial systems that are totally running in software without any intermediaries on the world. I think that's really disruptive and kind of a really just, why not? Like,
Mhm.
and really cool to think about. At the physics level, people often ask us like, well, Nasdaq has like sub 1 millisecond trades. How you ever compete with that? Reality is that news, like information around the world, travels at speed of light through fiber. Like it still has to go through speed of light through fiber. Some event happens in Moscow and Hong Kong, then information travels speed of light through fiber to a terminal in Bloomberg that a trader looks at. Well, at the same time, a state transition through Solana, right, can be inserted at Moscow and propagate through the network through Solana, right, for that market. So when the trader actually looks at a price at the New York Stock Exchange and a price on a market like Serum running on our information network effectively,
Mhm.
that price is already reflected. That for all the important newsworthy trades, you can have instantaneous global clearing and settlement, like execution and clearing, and then some settlement layer can do that later. So that's pretty fundamentally different than these centralized systems where
Mm-hmm.
you have to jump through a bunch of hoops to get your connection, to get a box in, and then somebody that pays more has a higher priority than you, you know.
Mm-hmm.
I think that could really, in my mind, transform finance. We could be, 10 years from now, we could be living in a world where 100 million people put in 1 cent into, your house purchase in San Francisco.
Um, so there's, I want to get into the specific technicals behind, proof of
Yeah.
history and why Solana or how Solana works. But before that, I want to give some context here. So, I was kind of looking into what Solana, how many transactions you guys are doing right now. Looks like you guys are doing like, between 500 and 1,000 transactions per second. But this is like these are real transactions, right? These are not just test transactions. This is like
Yes.
real world
Yeah.
activity, right? Happening right now, right?
Yes. So 20 million a day serum. About half of those transactions are consensus messages themselves. So it's just nodes using the network themselves to synchronize. We have a different design from a lot of networks because we're optimizing for that core censorship resistance piece, where nodes that are participating in consensus, their votes are themselves signed messages that pay a fee, that have to pay a transaction fee like everything else, because they are competing for the same information resources as serum markets. That it's not like a system where you have one platform and then that allows other applications to run. It is like the shared pipe for everything. So about half of those, about 50%, are consensus messages. So I wouldn't want to count those as user data. About the other 40% are serum. Like this is a central limit order book built by the folks out of FTX initially. Now it's its own community and like community run project. It operates just like a central limit order book does on NASDAQ or on Binance or on FTX. So there's a bunch of market makers that are constantly submitting orders, cancels, and that thing does 200-300 times more transaction messages than Uniswap. But that doesn't mean that there's that many more users, right? Like it's just Uniswap is a different kind of financial system that is constant function market makers. They're super cool design, but it's not the same as like a market maker driven central limit order book. But that is real businesses, real market makers, real traders trading on this thing. So that's real activity.
It's yeah, it's definitely fascinating. So I mean, Serum, for those who don't know, it's basically an exchange, right? You could basically buy different currencies, exchange them, and they're running on top of Solana right now. They chose you guys mainly because of these characteristics where you could have an immense amount of output or throughput transactions per second, but they're extremely inexpensive, each transaction. Can you give us an idea of like how much each transaction costs? I mean, I guess it varies according to the amount, right, of each transaction or the value of the transaction.
It's not value based, so it is it's more the token, right? The SOL token is there to prevent spam on the network. Part of what could be causing spam is CPU time, right? Data, like storage, etc. So our target for the cost to use the network based on current global bandwidth prices is about $10 for 1 million messages. So that's, I think, 10,000 times cheaper than Ethereum. Or I mean, it depends which Ethereum you're looking. The way I think of Ethereum when it was still 10 cents a transaction. Now that it's $100 per transaction in Ethereum, it's 10 million times cheaper than Ethereum is today. But again, who we set our sights on was NASDAQ, which I believe their message rates are like 0.15, something like that.
Got it. So, I mean, you guys got this, you got your working protocol up, you've got, it tested out, you have real life transactions, 500 to 1,000 transactions per second happening right now on the Solana blockchain. This is not just theoretical. We're going to release this in 2 or 3 years.
Yeah.
What's like do you what are the limitations? I mean, can you guys do you have smart contracts, the ability to put smart
Yeah,
contracts on your blockchain, and is it any different
yeah,
than Ethereum and their approach?
yeah. It's quite different. EVM is like one of the another thing that I feel like is holding back the industry. EVM is a really kind of slow sequential virtual machine that's stack based, that's got these massive 256-bit values. It wasn't designed for speed in any way.
For those who
And it has
don't,
this,
for those watching who don't know, EVM is the Ethereum virtual machine that basically runs the Ethereum network. Go ahead.
yeah, it wasn't built by folks that have been like optimizing virtual machines for a decade. uh, so uh, we are using Berkeley Packet Filter, which is a virtual machine built by the Linux kernel community. It's designed to execute inside the Linux kernel. So it has the highest security requirements out of any VM out there, but also the highest performance requirements because it's used for network switch operation. So BPF on its own has been demonstrated to do 60 million packets per second inside the Linux kernel. So it kind of has these really nice uh, optimizations that make it really easy to optimize it on modern day hardware. So this is why we chose BPF as our target virtual machine. So the way that you use it is Solidity in Ethereum has this implementation that's also the standard, kind of one vertically integrated thing where Solidity compiler spits out EVM bytecode that's executed on the EVM virtual machine. Uh, BPF, because it's a standardized language, has LLVM as its compiler, which is a standard compiler used by Apple, Intel, NVIDIA, Qualcomm, you name it, to compile any number of front-end languages. Right now, we are primarily focusing on Rust as our smart contract language. And it's kind of, if you're familiar with Java, C++, you should be able to pick it up in a week. It's a modern version of this, so it has a lot of advancements in type theory have been adopted in Rust. It was built initially by the Mozilla team, but is now, I think, it's been voted number one as the most favorite language by GitHub engineers. I think it's in the top 10 or top 15 in terms of popularity on GitHub as a language. Most modern blockchains themselves are built in Rust, which is interesting. It's being proposed as a language for the Linux kernel, which is kind of mind blowing to me because I worked in the Linux kernel and it's all C, and Linus has been like so adamant about rejecting C++, but I believe he sees in Rust what I see in Rust, which is a really nice, clean implementation of a modern type system on top of a language that is really optimized for hardware.
Awesome. So in terms of smart contracts, I mean, if you guys can do smart contracts, you guys are proving, your throughput and your transactions. Um, why why is there a need for Ethereum 2.0? Like, what's the point?
So the philosophy of like Ethereum is still kind of, I believe, straddling both of those worlds, right? One is, I think we're primarily focused on information flow. How do we build this super connected world, right? How do we simulate censorship resistance to the level that you can't differentiate that from, if everybody in the world had like neutrino lasers that we could unobstructedly use to talk to each other, right? That's like the physical network that we're trying to build. Um, Ethereum is really focused on this idea that you can replace proof of work or self-sovereign money or store value with proof of stake systems with a massive number of them that all verify each other. It's interesting. Like I don't know if they'll succeed, but it's worth trying. This is what they believe, right? Like it's an open source project, open source community. Um, because the space, like the trade-offs are Pareto efficient. You can't do one or the other. There's absolutely zero chance that central limit order books are going to run on Ethereum, ETH1 or ETH2. Like that kind of scaling, they're just not doing. Um, I kind of I suspect that if we succeed in our goal of really truly building this massively censorship resistant system such that it takes 10,000 independent parties to collude to disrupt the flow of information. Um, I think the properties of store of value will emerge there as well, because I believe that the proof of work piece isn't necessarily as important as the number of people involved with cryptographic keys that are all signing the same kind of state. Like the real security, is the people at the end of the day, right? We can all reject proof of work and switch to something else, right? That Bitcoin state machine could be running on Solana, and if if it's 1,000 people, it might not be worth something. But if it's 100 million, if it's a billion, then all of a sudden the same properties that you see at a proof of work will start to emerge just from this idea that a billion people can coordinate over the exact same state. Um, and but that's we'll see if that happens. That's kind of a unknown still.
Hmm. Got it. Um, I mean, from what I'm hearing, you're saying that, with Ethereum 2.0, they're still trying to they're trying to do both, the best of both worlds in their view, trying to
Yeah.
solve the store of value problem, as well as trying to improve their whole, transaction information flow problem. But in your view, they're compromising on both, basically.
Yeah.
Um,
Yeah.
they might not be as good as Bitcoin in terms of store value, and they're obviously not as good as, for example, some other projects like Solana on throughput and information flow. Um, how about
So
Lightning?
there's no other
Okay.
project that is actually like really committed to this idea of maximizing censorship resistance.
Huh.
There's not one. I honestly feel that we came out at this with a really like in the unique quadrant. Like,
Uh,
how do we solve this problem and only this problem as the fundamental thing that we're working on?
okay. Okay. I want to ask about this. So maximizing censorship resistance. So, um, like, what does that mean exactly? I mean, because all blockchains and crypto will say, "Hey, this is decentralized, secure."
Okay.
So meaning like, things flow. But in terms of why do you say that you guys are the only prop?
Security comes from cryptography,
Mhm.
right? In any properly implemented layer one, if my keys are not leaked, nobody can steal my funds, right? That's impossible, right? Let's say I have some keys that represent USDC. So Circle is the thing that's providing custody for the dollars in a bank, and I have digital representation of those with my keys that I hold. The intermediate network, if it's 100% corrupted between me and Circle, no matter what they do, they cannot steal my keys because there's no way they can convince Circle that I signed a message that says spent Anatoly's dollars. So the fundamental security of value is my keys, right, between me as a peer and Circle. Um, so all of these layer ones, unless they screw something up horribly,
Mhm.
should be secure.
Mhm.
Then the question is, can they guarantee liveness or consistency, right? Can they guarantee both of those properties to a very high degree? Um, and that's the hard part. So the the challenge for censorship resistance is that it's really hard. Like it's really hard to guarantee that you have the performance necessary to handle that a very large set of nodes that could potentially disrupt the flow of information because that set has to be super connected. They have to process all of each other's messages. If they don't, then there's a smaller set that can do it. Right. So there's that minimum set, maximizing it means maximizing the amount of data, messages, cryptographic signatures that all the participants in the network have to read and write. And that is kind of a problem of hardware optimizations. How do I you know, how do I go and like take this cryptographic operations, move them to GPUs? How do I move them to CPUs to, single SIMD, AVX, whatever have you? How do I minimize the amount of time it takes to read packets from network cards into the kernel, right? Like it's not computer science. It's just kind of blood, sweat, and tears engineering.
Mhm.
So like doing that is just hard. Imagine, right? Like USDC, USDT, those are the top traded base pairs on exchanges, or right? And the the value of who owns USDT, or that information, who owns USDT and USDC, is traveling across between exchanges. If the only network that that information can travel through, let's say, is Ethereum, and it takes 5 mining pools, actually 3 mining pools, to hit up to 51%, then those mining pools decide whose dollars get to travel from Coinbase to Binance to FTX first, right? So they get to prioritize which financial institution gets to take advantage of any market opportunity in any of these marketplaces. So just three entities, right? They get to pick, right? And right now, because crypto, I think, is still quite immature, it's not a huge problem. But we start seeing that being a problem in like things like miner extracting value, in flashbots, and things like that are looking at trades and mempool and get to prioritize which trades or which blocks, and how me as a miner, how can I take advantage of that information, right? That when I'm constructing the block, and extract the value from the users and from the network. So that bit, like that amount of information and value that any of these block producers can extract, it really depends on what is the smallest set, right, that control the network, that have the opportunities to do so. If we maximize that set to 10,000, right, or some large enough number, then it's effectively an open, fair marketplace, because information can flow freely, because it takes so many of them to really collude to disrupt its flow.
Got it. I mean, so you're saying that with Ethereum or some other chains, like if the mining pools are more consolidated, you have big players, that inherently, I guess, allows for more censorship or more opportunity for them to take advantage of that extra information that they have at the moment.
So, but fundamentally, that's a different form of censorship than I have my Bitcoin. There may be 5 mining pools today that won't let me spend it, but 5 years from now, there's going to be another set of mining pools that may, right? That Bitcoin guarantees that eventually somebody will accept your Bitcoin, because your Bitcoin is safe and secure. But because it's safe, and the guarantee that it's safe and secure from reversal of this fork, right? Of like somebody replacing the current ledger of Bitcoin with something else. And that's what gives this kind of, loop of self-sovereign money, right? It's its own money. It's hard to buy it, right? Because we're not talking, it's hard to analyze and hard to accept it as a truth, because it's not the same as like understanding dollars between exchanges moving, by hedge funds, right? That's like almost like a simple software problem. How do we guarantee that this is a fair market? Well, SEC and like a bunch of financial regulation in the United States guarantees it at the physical level, right, between all of these exchanges and financial institutions. There's enough regulation that they can't, screw each other. But how do we do it in an open environment around the world, right? Open price discovery engine where anybody can participate. There's no global set of regulators that say you can't do this, and that would be impossible to enforce anyways, right? So, and we have the opportunity to do this with commodity hardware and software. So that's, I think, both the challenge and the opportunity here.
Interesting. I mean, with Bitcoin, in terms of censorship resistance, would you say that they have censorship resistance? It's just more limited. It's not maximized in terms of information flow, but at least it's there with. It's not.
It's different. The idea that if you have Bitcoin and you try to spend it, that eventually some honest block producer will pick it up and spend it, right? It's that given unlimited amount of time, Bitcoin can provide extremely high degree of censorship resistance. But it doesn't guarantee immediate information flow.
Got it. Yeah. So in terms of maximizing, especially with information flow, there's major limitations. I'm wondering, what do you think about Lightning? I mean, some people are saying, hey, the second layer solution, Bitcoin will transform Bitcoin into this payment network. Maybe it solves the information flow problem. I mean, what are your thoughts with that?
Does anybody need payments for Bitcoin? I feel like if payments was such a really killer use case for Bitcoin, then there would be Square app and mobile that was in between, like was good enough in terms of security that would let us send, wrap BTC and Solana to each other. Is that something that Bitcoin even needs or care or anybody that's using Bitcoin even cares about it?
Hmm.
There's some small percentage of people, right, that are all working on it, but I think it's not like a burning fire of a problem for Bitcoin. I think Bitcoin is functioning as a kind of this like settlement layer between exchanges. That's an interesting use case.
Yeah. I mean, what's your take on the future of payments? I mean, does crypto, do you think, play a role where we're going to be, transferring just tips and different, money back and
Totally.
forth across, you know, different to different people across different geographies, or do you think, um, and like, do you think it's just going to be for a blockchain that's meant for that, that's designed, for payments?
There's nothing that you would design differently about that blockchain than already doesn't exist on Solana. Like in terms of the hardest problem, how do you make them is censorship resistance at scale because the network has to be massively decentralized and has to be insanely high performant to handle market makers like that are sending, 300 more cancel messages per trade for a single trade. So in terms of kind of performance and loads, Nasdaq style like real time trading is a much harder problem. Um, I think payments is it's also like this was like the story of 2018, 2017. Is payments going to be big?
Yeah.
Possibly. Like I think the interesting part there isn't the peer to peer send you dollars. You can do that with Venmo already. Um, what's interesting to me about it is how rapidly teams can innovate and custom design products and kind of bespoke solutions for smaller networks, for like merchants, for like smaller groups of people that like maybe communities in Reddit. Um, all of this stuff is really hard to do. It's hard to do this long tail of development where there is still financial, you know, money being spent, money being shared between large number of parties kind of collectively getting together on the internet. That's really hard to do with Venmo, right? Like Venmo doesn't have this like run your own code kind of system, right?
Mhm.
uh, but blockchains with smart contracts do. You could, start like I don't know if you're in Reddit, right? There was a
Mhm.
Secret Santa on Reddit, which is awesome that they kind of stopped. But you could build a Secret Santa payments coordinator to presents to NFTs thing on Solana, and you can't do that with Venmo, right? Like it's just like that stuff doesn't exist or is hard to build and deploy in centralized systems because underneath the hood, right, on a centralized system is a big pile of regulatory overhead and licensing that really prevents them from shipping anything like really
Mhm.
quickly.
Mhm.
Um, the cryptography, my keys, your keys, that's what allows devs to not be custodians of any of the funds, to truly just build applications that plug in these, my information and yours in a trustless way. And that's what allows them to iterate like much, much faster than anything in traditional finance.
Mhm. Um,
So
Interesting. Yeah, I want to unpack this a bit. So, I mean, you're saying that Solana has everything you need for payments, right, to establish a payment protocol. But to clarify, are you saying kind of like more simple payments, just like $2 to somebody to tip somebody? Do you think crypto has some
so so
fundamental
Metaflex
disadvantages
is no like
compared to
it's
Venmo
just
or PayPal or something?
it's those already exist. So how do you
Mm-hmm.
replace them?
Mm-hmm.
Like like why would I
Got it.
like why would I use anything else if me and like my friends all have Venmo?
Yeah.
right? There has to be
Yeah.
something that Venmo can't do that this thing can do,
Got it. And
something that I need to do,
got it.
right? Like I have to have a need to use it.
And then you're saying that there could be more advanced types of payments, like let's say the Reddit Secret Santa type of structure that is more suited or has an advantage, crypto has an advantage or something built on Solana, for example. But I mean, some people, I mean, okay, why do they call it cryptocurrency then? I mean, in terms of the currency aspect, I mean, that's like it's meant to currency in a sense. You exchange it for like everyday stuff, but I mean, would crypto
Because
assets be a better or crypto something else? Like, I mean, what are your thoughts on this whole
Bitcoin,
thing?
because Bitcoin is self-sovereign money, right?
Mhm.
It is it's money that is issued by a decentralized network and is secured by electricity. So it is Bitcoin is equivalent to the government issuing dollars, right? Like it's a currency. It's so this idea that that you could even do that is kind of mind-boggling, right? Like you got to unpack like 10,000 years of history and like kind of dig into like where did money even come from to even comprehend that that's possible. Um, I don't.
Yeah.
So do you like if you accept that, right? Like if you can kind of convince yourself that Bitcoin is money,
Okay, wait, let's.
right?
Okay,
That
I want to actually push back about on that a bit. Let's say hypothetically, someone says, "Well, Bitcoin is only money because people believe it's money. Like anyone can copy the GitHub code, right? Fork it, create a new Bitcoin clone, and say, "Oh, I've created, the next government global reserve system, money, currency, whatever." But no one believes in it, so it doesn't mean anything. What if it's only the belief that that has value that's giving its validity toward it's being it's money and currency?
so with I tend to agree with you. That's kind of an unproven. We haven't tested that yet,
Mhm.
and the only way we can test it is if we can get 100 million people, a billion people, all coordinating over the same state, right? The same token on some other network that is proof of stake, has nothing to do with proof of work. The only network you can do that is Solana. So I am curious. Like I want to see this experiment play out. Can you build a token like a social token, a community token for a group, like that, replaces advertisement with just the token being traded amongst the people, giving each other tips for jokes or whatever. If that scales to 100 million people, 200 million people, a billion people, will that social network, that coordination, right, that belief that this thing has value simply because it connects me to this massive group of people around the world, is that going to have the same properties as store value? I tend to think so. Like personally, I think that the power, the innovation, like the true innovation in the space, has nothing to do with the layer one proof of work, proof of stake stuff. It's empowering individuals with cryptography, like consumers that are able to sign messages, like sign cryptographic messages with ease, was just impossible before Bitcoin.
Mhm.
Um, like you had to get a certificate from VeriSign, like you had to like go pay hundreds of thousands of dollars to license like stuff from RSA or whatever. Like all the stuff was really crufty and like broken. Took me 6 months of meetings at Qualcomm to get a piece of code signed. Binance signs a million things per day.
Mhm.
Like MetaMask users, right? Sign a bunch. If you use MetaMask, you generate the same signatures with the same hardness and security as Google does for its internet certificates. But this is now distributed amongst people. And if you have a billion people that can do that, I believe that unless the internet is totally disrupted and walled off, some solution will come up to coordinate them. It's just kind of like, there's the market, go figure it out, right? Like, I think we're the closest to for that to be a possibility, but I honestly believe and at the end of the day, it's the people armed with cryptography that are more important than proof of work or anything else.
What are your thoughts on Dogecoin? Do you think there's some legitimate chance on Dogecoin becoming like one of the major type of crypto assets out there, or do you think it's just like a fad? What are your thoughts?
So this is again like this idea to is the power in the technology or is it in the community around it? If that community grows to 1 billion people, right? Like then that becomes a very powerful thing. It's 1 billion people with cryptography. That cryptography represents shared state and this Dogecoin Merkle tree
Hmm.
or whatever, right? Like that that is a very powerful thing. And if it can grow to that, then in retrospect, we'll say it's inevitable, right? It was the funniest joke. Why wouldn't people do it? But like it's hard to predict this stuff. Um,
Got it.
I think Bitcoin has like has a really good meme, right? It's a bit more serious, which I
Mhm.
think people buy into, but I personally don't know. Like
Yeah.
this is beyond my engineering expertise and more into like
Yeah.
history, social
Yeah.
analysts,
Yeah.
analyzing like the social impact of money and things like that.
Yeah. It's like Bitcoin's memes are very powerful in the sense of like it's like FOMO, right? Missing out, but also like the Fed printing money, um, kind of this anti-establishment, message. Do you think how important is our cryptos? Is the meme is a meme to a crypto? Like we're talking about, this whole role of community. Like with Solana, how important is the community and let's say the greater adoption or popularity to your success versus proving it out with just technology, like a tech startup, for example.
Yeah, community was like really critical for us because of how hard like this technology is to build and deploy and test. And we, like I thought to me it was obvious that there's going to be enough people out there that are like, oh, you want me to like go call up a local data center and ask him if I can build a box and run your validator? I'll do that, right? Like I think this is cool. I thought that there would be enough people, but a lot of people thought that there's no way this will ever get off the ground because of how hard it is. Like, Ethereum nodes are very easy to run. You can run them on your laptop. We get a lot of flack for that because it's hard to do. It's hard to run the network. But it ended up that our community is that of like builders that are kind of geek out on this stuff. They want to build their own servers. They want to like go call up a local data center because that's their buddy's ISP, right? That's like it's a much more kind of like small business kind of like folks getting together and building this out. Um, and that really kind of set the culture in our community for builders, for people that want to get hands on and solve problems and like really solve the hard problems, like work on the hardest computer science or software or hardware problems.
Mhm.
And
Good.
that like you can't buy. There's no way like you can you can like construct that. So we've been really blessed with how that turned out.
Mhm. Um, I'm curious. Like you made an interesting, point about Solana really being, I guess, prepared and ready to be different use cases. Like for example, a currency. Um, we're talking about the whole role of memes and community. Like, what is Solana's meme? Like, is there something that have you guys thought about it? Are you guys pushing a meme or something?
We
Like,
can't push a meme. That's the funny part. Is there's no way you can push it because then it'll just horribly fail. And one meme that sprung up were these folks that wanted to wear these glasses called pit vipers. Let's see if I can
mhm.
have some around here. One sec. I'll find a pair. I don't even know where this meme originated, but all of a sudden, everybody that was talking about Solana was wearing these. So when I went to like Bitcoin Miami, there were a lot of people wearing these glasses that just I could kind of knew that they were fans of Solana. Um, I thought they were cool because I'm a cyclist and these are nice cycling glasses, polarized, white brim, look shiny. But, you know, we have memes, but I don't know where they come from, to be
Got
honest.
it.
It's so weird. Like it's just once you have enough people together that are sharing something, um, just kind of culture starts springing up, like evolving. Um,
Yeah. Um, I wonder, like with Bitcoin, part of the memes of FOMO and store value, it comes from the problem that they're trying to solve, right? That resonates with people. Um, with Ethereum, you have more of this whole kind of DeFi movement of whether it's lending or NFTs or, exchanges, all this stuff. For Solana, like what is that problem you're trying to solve that really is defining Solana for the time being? And,
it's the censorship resistant piece. We really want to build that, maximize the minimum set of independent parties that could disrupt the flow of information.
I mean,
So the,
it sounds great. I mean, okay, so theoretically, I get it in a sense, like, for example, your whole pitch thing of like, crypto for like NASDAQ speed, right? Information flow, you're really solving, and it seems like, yeah, if you can solve that, then you can solve like so many other use cases because like, that's like one of the ultimate use cases of information flow. And if you can make that decentralized, centralized, or censorship resistant, then it's like everything else seems like it would be easy in some ways, right? I mean, that seems to
yeah,
be like the case, but does that solve the a nagging problem for the average Joe on the street, like who's just like,
well, I,
mm,
like you look at the rate of yield, right, on these DeFi platforms, and it's 1,000 times higher than what you get out of a bank.
mhm,
And that's because there's no intermediaries between the value creators, right? You have application that's getting users, right? It's really hard to get users. It's really, really hard to build a community of business. Those are value creators. And then you have like market makers. It's really hard to synthesize all of this noise into risk, right? Into capital position at a risk. Um, and if it's running on blockchain, there's no intermediaries, and the users get yields that are 10 to 15%
mhm.
with software that gives you clear expectations of risk of like what the risks are. Um, and you can't do that in traditional finance. Joe in the street doesn't have access to that through Bank of America, despite all of this like stuff that they've built up, right? Um, so I think immediately we can transform how people treat money, right? Like how people deal with savings, with finance and manage risk. Like I think that could be transformative like today.
Uh-huh. I mean, it's, I mean, uh, I hope you don't mind kind of this becoming a dialogue conversation in a sense, but
Yeah.
like Ethereum seems to pitch that a lot, oh, it's, take out the intermediary, get higher yields or bankless, whatever.
Yeah.
Um, is it any
Well,
different?
Ethereum's trying to be everything, right? It's also store value. It's also
That's
ultrasound
true.
money. It's
But
also this.
yeah, but with Solana, like, are you guys, is there a case where you can make to the average Joe that you're doing that better?
Yeah, because we've optimized for this censorship resistance piece, that
Mhm,
means that more users can participate at lower costs, right? They're
mhm.
not dealing with fees or slow execution times. More market makers can participate. They can put more capital at risk. That
Okay.
and like those returns can be better and bigger, right? That we can
Yeah.
actually do that part.
Well, can your yields actually be better or bigger compared to
In theory,
in theory? Because
as volumes grow, right? Like
uh
if volumes grow in Solana to be 10x of what's in Ethereum,
mhm.
which I think is a completely possible, or 100x, then those yields will get higher, and just you have more liquidity and more opportunity to kind of dial in. I want this much yield for this much risk.
Got it. Does solving for the censorship resistance, does that make you the fairest crypto out there?
It makes the network the fairest, right? Like, what is
Mhm.
fairness for crypto? I mean, I always think of it as this like information flow problem.
Yeah.
And if we solve that, right, like if we build a technology that really allows you to scale that censorship resistant piece, I think that would translate, over time into the fairest place, in the
Yeah.
fairest digital space.
Yeah. I mean, it seems like with what I'm hearing, so I still want to get into the technicals, but what's fascinating with all this talk about community memes, popularity, all this stuff is that like I'm understanding that in a lot of ways the technical issues you guys are solving, which seems so fundamental, like information flow, censorship resistance, like market dynamics. If you could solve for, NASDAQ type of market info flow, then you solve this for so much. But then to translate that into the average Joe, the person on Reddit or Twitter, to have some felt need, like they need to feel like some type of
Yeah.
thing about, and
Yes.
information flow doesn't really resonate,
Well, the most unfair markets right now
uh-huh.
are like social networks, right? You go to
Yeah.
Reddit, you're in a part of some community,
Mhm.
there's somebody that's taking your data and then converting it into an ad that you don't want,
Mm.
right? That's a
Mhm.
that's a market. Um, I believe like you already see some semblance of this that communities like Cope, for example, they have a token. It's just a community token. It's just for fun. Um, be part of that community, you got to go get that token. And one monetization strategy would be like this platform that's running this could earn some return, right? Like they could actually get fees from the exchanges. And if you think about that, right, you have a network of people with a token that's just karma, like Reddit karma or like jokes, right? It represents something fun about that community. Um, and the platform's collecting fees from the exchanges, then everybody is happier the more interactions and more fun people are having because there's more trading or more exchanges going on, and there's nobody is incentivized to steal your data and feed you information that you don't want, right? Like that's a
Mhm.
you took like an unfair market, right, and made it a fair and open one. That's really disruptive if it's possible, but you need to be able to execute this exchange of information cheaper than a Google ad, which
Mhm.
is zero point 0.2 cents, right?
Got
Like
it.
it has to be
Yeah.
dramatically cheaper than that.
Yeah. I mean, the
Um,
interesting example of that was what's that audio music company that's on Solana right now?
Audius.
Yeah, Audius. So I was listening to an interview with Audius and kind of addressing some of that, like building a whole social network on top of a blockchain, which is kind of this theorized use case that people have given, but it's exciting to actually see it happen. That
It,
they're
it
actually,
already happened.
yeah.
So DeFi Summer was more about the social part of it,
Mhm.
like this rapid formation of people around a meme, like all coming together around a single joke or meme, like around the world, like really, really rapidly. And that was 30, 40,000 people. So imagine as we get to a world where there is 500 million people that have cryptography that can be used to coordinate and come together into a social network. Like that's, if that was 30, 40,000 people that was causing DeFi Summer, imagine 300 million, 400 million people all doing that at once.
Mhm.
That's like what this technology is unlocking, like what the cryptography side is unlocking. Our
Mhm.
job is to just make it possible for that coordination to happen the cheapest possible way,
Mhm.
and the most censorship resistant way, because I think it should be obvious to everyone, right, that you really want to eliminate the ability for anybody to interfere with this large group of people communicating.
Mhm. Um, I know you guys, have a tremendously low transaction fees. Is it possible ever to get to like close to zero transaction fees, or is there something inherently about just you have to
Yeah,
reward and
it's
incentivize,
in
the
in
network?
in so in theory, um, like the way we've designed it at the hardware level is that the parallel number, like the number of parallel events that could be processed, that's scalable with Moore's law. So it's not that like you and me could double the amount of bits that we're sending, the amount of transactions we're bouncing between us every 2 years, but the number of people that are simultaneously interconnected, right? That could double every 2 years because Intel, AMD, NVIDIA, Samsung, like all the network card providers, they're doubling their bandwidth every 2 years. There's twice as many pins, twice as many cores, you know, twice as many uh, transistor, like the twice as much storage and SSDs. Like all that stuff kind of goes up every 2 years, and that Moore's law is something that we're taking advantage of. And this is a EVM problem and kind of a runtime execution problem, but it's also a consensus problem and a network transmission problem and a storage problem. We've really just kind of 100% bought into this idea that that's possible and should be done. And um, Ethereum and a lot of other protocols have not. So we have a different philosophy around this.
Mhm. Um, why? I mean, in some ways, like a lot of this stuff, it sounds like a little bit too good to be true with Solana. Like when I look at some of the stuff, so I wanted to actually ask you and to figure out like what are some of its weaknesses. For example, like if you guys have really cracked the code in terms of low fees, scalability, even security, like why are
So
there other why are people still using, Ethereum? Why is there a Uniswap or a Compound or Aave or different, stuff happening in Ethereum? Like, or can we expect a lot more stuff to be happening on Solana very soon? Or are there some inherent disadvantages that Solana might have? I mean, what's your take?
um, there's two questions there, right? Like why hasn't all this activity moved over?
Mhm.
And the other one is what are the weaknesses to Solana? And the weaknesses are that it takes a lot more individual upfront time for you to go call a data center, right? Like some of them don't even have a website or like it's a really busted website. These are like small shops that just connect cables, right, and provide power. Go call them up, see if they have, 8 units of space for you or however much you need. Go build a system and go deploy it. That's something that is a barrier to entry for most people, but it's necessary because can't like run the next generation financial system on Raspberry Pis on laptops. And Tarun described this as like E2 trying to pull a cart with 100,000 chickens, and Solana's trying to pull that same cart with 10,000 horses. It's a lot easier to get 10,000 horses to go fast than 100,000 chickens, like
Mhm.
all in the same direction. So you can think of that as like those two sides of the problem. And the reason for that, again, comes from this idea that Ethereum really wants this long tail of chickens to all verify like the most concentrated pieces of the network. Um, so they're more worried about the store of value kind of monetary proposition of ETH. Solana is trying to maximize that set that can potentially block information. Um, and that's just two different approaches to different problems. So the weakness comes from this difference in like kind of fundamentally how we're looking at it. The only way to solve this maximizing this min set of it that could block information right now is really you just need more hardware. There's no way around it because they all have to verify each other. They all have to process each other's messages. It's a kind of a quadratic messaging problem. The only way to solve that is just by throwing hardware at it, um, which in some ways I think fundamentally breaks that from this idea of replicating what Bitcoin does with these chickens, right? Like everybody runs their laptop, they partially verify the state, and somehow this aggregate set of random people like doing this creates the same, security that you'd expect out of Bitcoin, right? There isn't like a proof that that's equivalent. We just hope that it is. Um, does that make sense? So like it's
Sure.
just fundamentally like the, the the use case that they picked is store value money as the primary thing. They will
Mhm.
not compromise on that, right? Solana picked information flow as the primary use case, and we are not going to compromise on that. And reality is might meet somewhere in the middle, right? But maybe like maybe it's possible that 1 billion people coordinating on Solana will capture the exact same properties of store value as um, done with mining and proof of work or this like 100,000 chicken approach.
Mhm. Got it.
um, the the other problem, like how do you get people to switch? So a lot of governance and systems built on Ethereum, those folks are there, right? They're coordinating state that's part of Ethereum. It's the Aave token, right? It's the Urine token, it's the Link token, or whatever. They are governance of systems that are executing on Ethereum. And those communities, it's hard to just move them over, right? Because that means they need to be governing systems that are running on Solana. So there's a bit of a network effect and chicken and egg problem. But in some ways, um, like I see some of that happening on Polygon. You see like Aave being migrated to Polygon and getting some TVL and traction. Um, and that's pretty cool. Solana is not EVM compatible, so you have to rebuild and restart these contracts from scratch. And while that seemed to me like a disadvantage early on, it seems like at this point that it's an advantage because what we're seeing are homegrown teams that are able to build their own flavor of borrow lending, of margin, of perpetuals that is redesigned from the ground up to take advantage of Serum, a central limit order book, which is a fundamentally different primitive kind of this base layer of price discovery than Uniswap. So this redesign process is allowing kind of massive leaps of innovation, right? People are not just copying and pasting and taking kind of like idea market share from on Solana, right? Aave is not the dominant lending protocol on Solana. It is on Polygon, but because it's not on Solana, it means that Jet, Mango, and like Everland are able to take their own twist on it and launch and kind of fight for it. And those teams have raised, over 1 million or whatever in funding, at least. So we had like 11 teams at the second hackathon that raised over 1 million in seed funding from a bunch of investors. Some have raised way more, like 5 million. Like so, it's been kind of awesome to see that happening. Like I was really worried that during our, this is like a lot of we took so many risks, right? Like new design, just totally proof of history. No one's ever heard of that. Uh, hardware optimizations for everything. Not using Solidity. Rust as a smart contracts language. Focusing on dexes when, at that time, up until DeFi summer, people like literally 3 months before that, somebody told me that dexes are dead. That like decentralized finance is dead, and finance is going to win everything. So. Um, a lot of those things came together and started working together over the last year.
All right, so I wanted to get into some of the technical stuff. So correct me if I'm wrong. Like part of the secret sauce of Solana is you guys seem to have a little bit of a different, unique goal or approach where you're doing this information flow, Nasdaq speed, like you're doing a whole nother level of what you guys are wanting to see in terms of transaction speed, but also costs and scalability. But you're doing this through kind of more of a hardware optimized approach, not relying necessarily on 1 million phones, right, to do the job. But also you're using what you call proof of history, which is different than proof of work and proof of stake. I've watched all the videos out there on this stuff, but I'm still like, I'm wanting to get some more clarity on it. You referred back to earlier in the talk about, hey, the security with crypto is based off of your keys, right? So you have your private key that matches the public key, then that provides the security. But how can you explain kind of the difference between proof of history versus proof of work and proof of stake?
Yeah.
And also kind of how you discovered that, and if there are any weaknesses with proof of history versus, let's say proof of work and proof of stake.
So, proof of work is a measurement of energy, right? It measures thermodynamic energy and your ability, like to gather ASICs, right? How much computational power can you gather, and how much energy you can put into it? Proof of stake is effectively a way for me to prove that I own that I own some public key that in some state machine represents some number, some weight that is maybe like my stake weight in a voting system. So me providing that proof is just me signing a message saying, hey, I am that public key. I have control of that private key, so I can sign for it. Um, both of those techniques are used to solve the Sybil resistance problem, which is how do I trust random people on the internet, right? I don't know if it's really Dave or it's a bot or right. Like when I see 1,000 likes on a tweet, is it 1,000 bots or is it 1,000 people? If those were proof of work messages, then I may at least know that it took $10 million of electricity to generate those likes. So if one bot did it and wasted all that energy, then at least that bot loves me, right? If I do it with proof of stake, then if the thing that is representing that stake has financial means, then I at least know that $100 million worth of capital was locked up and sitting in this ledger doing nothing and only used to vote. So I have some sense of kind of security there. Proof of history is a proof, but it has nothing to do with Sybil resistance. It's not a consensus mechanism. It's a way to prove that time has passed somewhere, that there is some difference between event A and event B that took real time to pass. So it's really hard to measure time remotely on the internet, right? Like I don't know if I'm seeing a live event or somebody playing something back that took, or it was generated on a computer, right? There's no way for me to actually tell. When I see, an image, like, and I look at it, when was that image taken? That date could have been manufactured at any time, right? Right there, 100 years before, 100 years after. So there's no, again, right? There's no way to do this stuff remotely without observing it directly. So what proof history provides, using a technique called the verifiable delay function, is is a way for us to compute that no matter how much energy you have, how much money you have, that two events encoded in this data structure took a certain amount of time between them. So maybe that was, and the way we measure time isn't in real time in terms of seconds, it's in terms of single threaded computational processing power. That's the fastest clock speed you can imagine is available out of a firm like TSMC or Intel. And that's a good enough bound because we know that going from 7 nanometer to 3 nanometer will give you, a 2x speed up, but it's going to cost you $50 billion. So I know that that the best you can do is spend $50 billion and go twice as fast. So I can kind of be certain that it really took about that amount of time between event A and event B.
Got it. So what's I mean, if proof of history doesn't solve the trusting strangers problem, what problem does it solve? Does it just solve the speed problem in terms of,
So
yeah, go ahead.
yeah, so it lets me solve the problem of trusting whether stranger A or stranger B created a message first, right? Like when they're trying to tell me, hey, I went before stranger B, if there's a data structure that links them, I at least know that's true, right? I can see that, and you can think of it. This problem, like one way to describe it is, imagine you're on an island somewhere